Well, hello again everybody, and welcome back to day 2 of the WoodPecker CNC build. And what we're going to be doing today is we're going to be building up the work table, which consists of these 4 linear bearings. We've got some precision ground rod here, which the table runs on. And we've also got the, let's just call it the nut, basically the nut which is going to push the table backwards and forwards running on this Acme thread. So we're going to assemble all that along with the stepper motor to drive the table. So the table runs on 2 of these rods. I don't know if you call them slides or rods. I suppose it's probably better to call them the machine slides. And I found a couple of little problems with these, one of which I probably can't do much about. I mean, I've used these linear bearings in the past, and in the past when I've used them, there's been pretty much no play whatsoever. But I can actually feel within the bearing itself, there's actually a little bit of play there. And although my hands are moving slightly, I can feel it rocking, and it just feels as though there's actually quite a lot. And I can't really give you a measurement for it. It wouldn't really mean anything if I did. But usually, or what I would say when I've used these linear slides in the past, there's absolutely no movement. In fact, maybe you can hear it better than you can see it. Can you hear it rocking? So can you hear that and see the little bit of movement in it? So they're what I would call in the trade a bit of a piss fit. I mean, they obviously run. I was going to say they run smoothly, but they actually feel quite rough. Oh, I'm good at that, aren't I? A lot of practice. Yeah, all a bit wibbly wobbly. Now, I'm not sure if you'll be able to see in there or not. What we've got is we've just got some rows of ball bearings. And that's what the work table of the machine is effectively supported by. It just runs up and down on that line of bearings. I'm not sure how many is there. It looks like there's yeah, I'm just having a look inside myself. It looks like there's 4 sets of bearings in there, 4 sets of ball bearing rollers. I'm not sure whether they are or not. They actually look a little bit like recirculating balls, but I don't think they are. Well, they could be, maybe. I doubt it. It's not a ball screw or anything like that. And one of the other little problems I found with these is they're not particularly flat, the bases of them. I don't think it's anything particularly serious. I can actually see what's caused it. These bearing supports, if you like, they're obviously been made on some form of 3D extrusion printer. And it looks like the printer's over extruded. So the base has got some nodules of plastic on them. I think you'll be able to see that. You can see some little dimples of plastic there. So these brackets, they won't fit flat onto the table. And just while we've got the table in front of us, the other thing I would say is this table's quite nicely made actually, but it is just an extrusion. I don't think it's been necessarily precision ground or anything. And it's not totally flat, although I went out into the garage earlier to look for a straight edge, and though I can't really show you on the camera here, the table is actually slightly hollow in the middle. Just looking at the way that this table has been cut from its extrusion, it must have come as a big long sheet of material, this, and they must cut it off. But it's interesting to say the way they've cut it. I'm just looking at the lines on it, and at first I thought that these had maybe been cut using some form of big bandsaw. But looking at this one, I can just see some little marks on here. Oops, hopefully you can see that on the camera. I'm not sure, will they show up? Yeah, you can see some marks on there, and to me that looks like some form of chattering. So I think that maybe these have been cut off with, well, I'm going to have a guess, they've either been cut off with some form of high-speed routing tool, or maybe they've been just trued up. Maybe they've been cut with a chop saw and then they've gone on some form of jig that's just just tidied up, just made the ends parallel to each other. But I can just see there's been, well, I can see it and I can feel it, but the pattern on it just looks like chatter, where the cutter has just been bouncing on it slightly like that. So right because the cutter's moved across, maybe it's been a little bit blunt, or the workpiece hasn't been clamped down as well as it could have been, and it's chattered on the surface of the material. Here it's fine, but it just seems to have, it starts to chatter there and it just gets worse and worse as it cuts across. So I suspect that might be something to do with the way that this workpiece was held down when it was cut off. So I've got in my hands here just one of the slides, one of the rods that the table runs on. And again, these look as though they've been cut off from some probably precision ground rod of some material. And just looking at the tooling marks on here, I can just see that the lines go straight across it. So these have been just cut off on a bandsaw or something like that. But a nice little touch, once they have cut this off from its stock, they've actually just taken the time to run it over a linishing wheel. So there's no burrs or sharp edges on that. And we always call things from China, talk about the quality that they provide, but that was an extra operation there. Somebody's cut this off and just taken the time to run a linisher over it just to remove the burrs. So yeah, I think that was well, hats off to you, nicely done, thanks for doing that, I appreciate it. Whereas we've got the Acme screws themselves here. Yeah, I mean, they're only relatively cheap. We haven't got ball screws, we've just got Acme screws. But I can see here that if you look at the end of this one, you can see it's got a little dimple on it. So this machine screw, this Acme screw, it's actually been cut off on a lathe. They haven't used a bandsaw, it's actually been on a little lathe here, because you can just see where they've faced it after they've cut it off. Again, same with that end. So they obviously maybe have this as a long rod in stock, and then they've just put it on a lathe, and they just part off these sections on the lathe to cut them to the length that they require. But again, nicely done. It's not particularly rough machining. Obviously everything's built down to a price, but I'm not complaining about that. Right, okay, so first thing I'm going to do is I'm just going to knock these bits of plastic off. Might as well do them all. That one feels okay anyway. I'm just doing these on a block of steel that I found in the garage. At some point I must have put this on my milling machine, and I can see the tooling marks on it. I've just run a fly cutter across it, so I suspect this is relatively flat, although it has got a few dings in it. This is just a piece of scrap metal I use for setting up work on my big milling machine in the garage. Here's the nut here. I think that'll do. Might as well just run these support brackets on here as well, although these look pretty good actually. I think that'll do. So just looking at the instructions, it's got a view here of the various components, and it's actually shown the pictures actually taken from underneath the table, if you like. I'm not exactly sure of what the correct order would be to actually assemble this table to get the best alignment, because really what you're trying to do is you want all the axes to be, I assume the word is probably perpendicular to each other, 90 degrees to each other, and if you're not careful with something like this, there's probably so much warp or inconsistency in the structure. If you actually tighten everything down, you'll probably find that the table will just lock up and not slide. So that might be a problem. So I'm thinking that basically the thing to do is just crudely assemble it and run the table backwards and forwards with everything just set a little bit loose, so that the table can actually just adjust itself and find its own position. Because if I just bolt everything down solid, then the table probably won't run. And I suspect probably one of the reasons that these bearings may be so sloppy is, again, if these bearings were super high precision, you'd find that they would just bind up. So they're probably maybe purposely using bearings here which aren't top quality, because they've probably got a lot more free play in it, which should just help stop the table from actually binding up. So far I'm quite enjoying this little build. It'll be amazing if this little CNC router can actually do anything useful. I suspect it won't be able to, but I'm going to learn quite a bit about CNC, stepper motors and CNC software. I have worked with CNC machines in the past, you know, great big industrial CNC machines, but I'm going back a lot of years. I mean, I think I've said many times, you wouldn't believe some of the jobs that I've been fired from. I must have done almost everything in my time. Very much, you know, kind of a jack of all trades, but certainly master of none. I could actually, if I wanted to, take this outside to the out to the garage, because I could just assemble this on the bed of my milling machine, and then I can actually I could have just used the milling machine as a reference just to set everything level. But as I said, I think the problem with setting things level, it won't necessarily give you the right answer, because all these surfaces are, I could set this dead level, but then when I actually screwed it down to the bed, when I screwed it down to this frame probably isn't level either. So you know, you're not going to win if you try and just level everything off on its own. When you come to fully assemble it, you'll find that it won't work anyway. I suspect the best thing to do is probably to have one guide blocked loose and the other one nipped up slightly. You can tell I'm just making up as I go along, aren't I? I don't know the answer. So we'll leave the back bearing supports a bit loose so they can float, and we'll tighten up the front ones. And what we'd really want to know is, are these two parallel to each other? That's what we'd be trying to achieve. Okay, what do you think? Are you impressed? Got to admit, it doesn't feel particularly smooth. Right, so I think the plan's going to be, I think we need to set this table to be in the centre. I'm guessing it really doesn't matter that much if it's not perfectly centred, but it wants to be roughly centred, and what we need to try to do is make sure all the axes are perpendicular to each other. So I think I'm going to call this slide here, I'm going to say that that's my my master. So I think what we'll try and do this, we'll set this one up correctly as well as we can, and then we'll kind of make this other slide on this side a slave to this one. Does that make sense? Am I explaining it? And what I'll do, just to help remember that, I'm just going to put a little cross on there to say that this one is our master side. Now, I don't know if what I'm doing here is correct. I'm totally winging it. I've never built one of these before. Although I have used, I can't remember the name of this rail. Somebody will know what you call this rail. Many years ago, I used to work in the newspaper business, and we used to build a lot of prototype machines, a lot of stuff using cameras to take pictures of the printing process. and we used to make some quite fancy test jigs and equipment like that. So we used to use a lot of this aluminium extrusion, and the only thing I really remember about it is that it was very expensive. I wish I'd nicked more of it from work actually. I just stole some. It used to be ridiculously expensive because I think it all came from kind of one company. So I'm guessing that all this stuff now is just being copied in China. It's maybe the patents run out, or maybe they don't care and they copy it anyway. It all feels very loosey-goosey. But I guess I haven't tightened the underneath up, so maybe we need to do that. Not sure how tight to make everything. These guide blocks are 3D printed, and I guess if I really tighten things up, I'm just going to crack the plastic. It's probably a law of diminishing return as well. Again, I think if I start tightening things up too hard, I'll probably just start distorting the framework rather than doing anything useful. Okay, everything does seem to have tightened up. It does feel very rough though, this. Feels as though it's running on well, it feels as though the bearings are full of grit. I mean, they're probably not. But it certainly feels very rough, that. So I'm guessing the next thing we have to assemble is this, well, I guess we'll call it a lead screw. And it's actually quite interesting, this. If you look at the nut, it's actually a split nut. So we've got a nut here, and we've also got a nut inside this bracket. And this is what pushes the table backwards and forwards like that. But the interesting thing about it is, as I say, there's a nut in here, and there's another nut here that I've got in my hand. And you've got to assemble these two nuts together like this. I'll just screw that through there. And what the point of this little spring-loaded assembly is, it's an anti-backlash device. It's there to it's there to take the backlash out of the screw thread, because that will cause you a problem with CNC machining. All machines have some backlash. Whenever you have a screw thread here, a male thread and a female nut, you have to have some gap between the parts. If there was no gap, it would be seized up, it wouldn't turn. So you need a gap, but the problem with having that gap, the bigger the gap is, the more you have some dead space. So when the thread changes direction, when you rotate this and then it changes direction, it actually takes a little bit of rotation to remove that backlash. And for a manual machine, you're kind of constantly fighting it. But the CNC can't really figure out, it's not really capable of kind of taking out the backlash automatically. So what you need to do is you have to use nuts. I mean, in a proper CNC machine, they have what they call a ball screw alignment, which basically is a very, very tight fitting nut, but it has ball bearings as the wearing surfaces, so it can actually rotate. Whereas if you were trying to achieve a very similar fit, a really tight fit with just a traditional brass nut like this, you wouldn't be able to do it. But anyway, I think that's quite a neat solution. I've never seen an anti-backlash nut like that. So it's two nuts with a spring loaded, with a spring between them to preload them. So I think that's quite clever. So there's that bit. So we've got to fix this to the underside of the table. I'm just having a quick look at the instructions to see if, does it go a certain way up? Let's have a look. It looks like we have to put this cutout to the front of the table. Well, I've got the motor assembly here, and what I've done is I've just gone ahead and mounted the stepper motor onto, I think that's a stainless steel bracket, and that went together quite smoothly, no problems there. One thing I did notice though is that there's not a separate thrust relief bearing or a thrust bearing, so all the force from the Acme thread is going to get taken back to the stepper motor. Now these stepper motors do feel as though they're quite robustly built, they're pretty heavy, and I can see that there is a roller bearing in here, so maybe that's fine. But certainly when I've worked on bigger machines, you would always have the shaft supported on some form of thrust bearing so that it isn't actually loading the motor. But anyway, this is what we've got, so that's what we'll have to use. Okay, would you like to have a closer look at this? So here's our stepper motor, and it's got a coupling shaft on the end, and that's designed to, well, all this really does, it just changes the diameter on the output of the stepper motor to match the diameter of the lead screw. I thought this might have been a flexible coupling, but it isn't, it's just a piece of anodized aluminium. Now these motor mountings are slotted so you can go vertically up or down. So what we won't tighten these up, we'll leave them pretty loose. Because again, everything will just have to find its own way. We'll install the lead screw now, and then we'll adjust the motor mounting for least resistance, I'm guessing. So it looks like we must need a support bearing for this side. Now we have got one of those support bearings, but that's for the cross travel. So I'm actually wondering if we don't have one for this side. Maybe it is that one. Oh yeah, I think it is, yeah. So come back, all is forgiven. Now just looking at this, it doesn't look as though I've got it very well centred. Have a quick measure around. That just lines up with the inch mark. That doesn't, so that isn't lined up. So maybe I haven't quite got my table in the centre. So much for all my accurate measurements, eh? 80. So about a millimetre out with these slides. I don't think that's going to make any difference, so actually. That's a millimetre out. What about to the edge of the table? That says 47. That says 50. So the table isn't, I've got the table slightly shifted to this left side. It's about 47. So I need to shift the table about 3 millimetres that way. But you know what, I don't think I'm going to bother, because I just don't think it's going to make any difference. I don't think I'm going to be, for example, using this bottom edge as a reference point. And if I decide that that's what I do want to do, then of course I can always go ahead and realign everything later. Doesn't feel as though these screws are quite long enough. I've got a feeling they're not long enough. I kind of think that probably I did that the hard way. I don't know. Oh, right, okay. Stupid me, I've tried to go too far with it. Okay, I'm an idiot. We knew that. Let's wind it back and do the back bearing again. Okay, so if I just turn the screw, we can see we've got a bed now that will move forwards and backwards. So I think that would appear to be a logical place to finish for today, wouldn't it? So thanks for watching. Until next time, that'll do. Bye for now.